Hi everyone. You might be wondering, what the heck is this? This is a virtual avatar. I actually just finished writing or creating a video for my grade 9s, and to keep their attention, I thought I'd try something new and have a person that's moving around in front of them. So maybe it keeps their attention and keeps them going with their math while I'm not there. And since it's open, why not use it for my grade 12s too? So yeah, hope you enjoy. It's a little weird for me too. It's actually really embarrassing, but yeah, bear with me. I tried to find an avatar that looks exactly like me. I got the hoodie down. That's great. But there was no sort of chubby avatar with a receding hairline. So this is the next best one. So bear with me. Oh, it's so embarrassing. I have 4 questions pulled from your handouts ready and waiting for you. I thought it would be a good example to showcase the various different strategies we talked about in class. You'll see the first ones. This is from the first page. This is the back of the first page. The next one is the back of the first page, and then the typewriter one. There's that. Okay. The video that you see now, I have put it up on YouTube and linked it on our Brightspace on the weekend, over the weekend. But if you're seeing this on Monday for the first time, yeah, just know that it is available on Brightspace and you can watch it again if this is moving a little fast. All right, here we go. So starting off, this actually, when I plugged it in, just to confirm whether it's an indiscriminate or indeterminate form or not, I actually don't get that, right? This is, if I plug it in, I have -2 squared, -2, and -2 over -2 squared, -2 times 3, and plus 2. What I get is 4 over a 0. So it's not an indeterminate form, but just to double check to make sure there's nothing we can do about it, I am going to go ahead and simplify, see if we can do something about it, see if something actually works. So as x approaches -2, we have -2 and +1, right? Multiplies to -2, adds -1, good. And this is x plus 2 and x plus 1. I think that's right. Multiplies to 2, adds to 3, right? These divide into 1. What I'm left with is the limit as x approaches -2, x minus 2, and x plus 2. What do you notice? When the limit is applied, you have -2 minus 2 and -2 plus 2. It's still a division of 0. This is going to be not in existence. And if you really want to specify, that is a restriction found in the denominator. This is going to be a infinity. It's going to be an infinite. It's a vertical asymptote. So anyways, there is number 6f, factoring, or sometimes expanding and factoring. Let's move on to a slightly more complicated situation. When I see a question like this with a root, my gut instinct is to try to multiply the conjugate. It may not always work, so please don't be discouraged if it doesn't work, but it's a fairly good first try strategy when you see a root. So that's what I'm going to do. I'm going to take this, I'm going to pretend this is not there. Am I able to cover this and sort of like erase it? Let's see. I want to fill with white. And my outline, I want it to be shape style. Okay, well, this is not the time to be looking at that. Here we go. I'm going to multiply this with the conjugate of the root so that I can effectively remove the root. Okay, it's a really good strategy. So here we go. Limit as x approaches 2. Let's see. A root times a root is whatever is the discriminant, whatever is the inside. The root is multiplied with +3. The negative 3 is multiplied by the root again. And a negative 3 times a positive 3 is negative 9. All over, I am going to leave this as is for now, because if I'm lucky, I won't have to expand and do anything about it. And I'm lazy. So we have these two canceling each other out. So I'm going to cross that out, leaving me with 4x plus 1 minus a 9. So as limit approaches, x approaches 2, we have 4x minus an 8 over x minus 2 root 4x plus 1 plus a 3. And just because I have this digital, I'm just going to erase that. 4x minus 8 is the same as factored x minus 2. So I'm going to rewrite this as x minus 2. And you know why I did that. I can effectively remove the indeterminate form. 0 over 0 has been effectively divided out. I am left with a limit of 4 over 4x plus 1 plus 3 as x approaches 2. And if I plug in the 2, I don't get 0 over 0. I think I can do it. This is equal to 4 over 4x, so it's 8, plus 1, that's a 9, square root, that's a 3, plus 3, that's a 6. So the limit is 2 over 3. It means when x gets closer and closer to 2, the y value will get closer and closer to 2 over 3. Okay, conjugate. Next example is going to be a little bit more complicated, so bear with me. At first glance, it seems like maybe because this is a cubed root, maybe you want to try using a conjugate as well. Another strategy that might work is to do a substitution, because if you remember, the thing with the 1/3, that might give you a hint from a question we did in class together. Another thing that you might see with 1/3 is you might have this inkling of using difference of cubes. I feel like all of them could work in one form or another. For our purposes, I'm going to try substituting something so I don't have to deal with a cube root. Okay, so the letter U, not mu, it is not the physics one, Daniel, it is U. And that is going to be substituted for 1 plus x to the power of 1 over 3. Okay? This, therefore, means what for the other variable? What does that mean for x? Well, I'm going to have to simplify and isolate x. I'm going to cube root both sides. So this is u cubed equals 1 plus x. And that means x is equal to u cubed minus 1. Okay, so this is going to be my substitute for one of them. I will have to use this to substitute another point. And also for the limit, if x is approaching 0, what does that essentially mean? It also means that u cubed minus 1 is approaching 0. That also means u cubed is approaching a positive 1. That also means u is approaching the third root of 1, which means u is approaching 1. Instead of writing the limit as x approaches 0, I'm going to say x approaching 0 is equivalent to u approaching a 1. Okay, so let's do it. Limit. As x approaches a 0, I've got, let's do the limit first. I've got 1 plus x to the power of 1 over 3 is the same as u minus 1 over x is the same as u cubed minus 1, and the limit is u approaching 1. Did I substitute correctly? Let's plug it in to test. You know that if you substituted 0, you get 1 minus 1, which is 0, and x approaching 0 is 0. Here in the same way, if u approaches 1, 1 minus 1 is 0, and 1 cubed minus 1 is 0. Well, there it is. Substitution. So we know we substituted correctly. Now we have u minus 1 and a difference of cubes. So here it is. Here's a question that does both substitution and difference of cubes. This would be the same as u minus 1 over u minus 1, u squared minus u, plus u plus 1. These effectively divide each other out, and I should be able to plug in and substitute the 1. We have 1 over 1 plus 1 plus 1, 1 over 3. As u approaches 1, my y value approaches 1 over 3, which is the same as when x approaches 0, my y approaches 1 over 3. There it is. This is both a substitution example as well as a cubic factoring example. The last example I have is for absolute value functions, and this is an example I did not do yet with, did I do it? No, I don't think I did it with my first period class. So listen carefully, please. When you have an absolute value, you have to test the inside. Remember, if the inside is positive already, then I don't have to deal with anything. But if the inside is negative, how do I turn this negative value into a positive? It has to multiply with a negative 1. And so that means x plus 1 is less than a 0, which means x is going to be less than a negative 1. Here are the two different domains that dictate where I use a positive x plus 1 or a negative x plus 1. So it's going to be two different cases. Remember that from our very first ever lesson on Monday last week. Here we go. So let's check. If the x happens to be greater than negative 1, we would test the limit as x approaches negative 1, x squared plus x over just x plus 1. You change the absolute value into a fixed expression. Okay. Now might be a good time to remind you that the question says evaluate each limit if it exists using appropriate technique. So if it exists means I have to confirm left side and right side are equal to each other. That's why I'm doing left side and right side of negative 1. Here we go. From here, I am going to factor, because I can see that the denominator and the numerator does end up becoming a 0 over 0. I'm going to divide out, leaving me with just x. And when x approaches negative 1, x becomes negative 1 by the limit property. If x happened to be on the left side, if it's coming from the, so this is the left-handed limit. The left-handed limit would use a slightly different function. X squared plus x over, right here, negative x plus 1. What does that mean? It means, well, same as before. I'm going to factor out the x. Oh my, what's happening? Something is lagging on my computer. X. Okay. Wow, something is really lagging. Maybe it's OBS or something that I'm using. So x plus 1, oh my gosh, it's spazzing out now. And my baby is crying. My life is crumbling. Let's see. Am I allowed to x plus 1? Okay, and that is all over. I can't even draw a line. What's going on here? I don't understand. Anyways, for whatever reason, everything is spazzing out. So I hope you understand. x plus 1, all over negative x plus 1. The x plus 1s will cancel each other out, leaving you with a negative x. A negative x, as x approaches negative 1, means that the limit is going to be positive 1. That means the left side, or the right side, and the left side are not equal. So this limit doesn't exist. And that's it. I'm going to stop this video before my computer explodes. I hope these examples gave you a even better understanding than you already had of the kinds of questions you might see. Just as a reminder for the quiz that you have coming up, please look at all the different ways we tackled limits and continuity, and whether limits exist or not, how you can confirm it, the conditions required to allow it to exist, what it means to be a continuous function, how to confirm continuity, I said that, limit properties, and how to remove indeterminate form. Okay? Again, looking at my mouse, my computer is really having a hard time. Hope this is good. If you have any questions, you know how to reach out. Best of luck to you, and I'll see you on Tuesday.